Hello friends, I hope you are doing well and welcome to Login Science. This is our lesson 6 of 6 on sequences and series. Today's lesson will be on sigma notation. Okay, before I can start with our lesson, I'd like to remind you and encourage you to subscribe to your channel and activate the notification bell so that you can be notified every time I post new content for you. And you can see down below is my name and the email address at which you can reach me. If you have any question or anything that you'd like to let us know, just feel free to use the email address provided down below. Okay, let's start with our lesson of today. Okay, today's lesson is on sigma notation. Okay, this is the sigma symbol. The sigma symbol stands for sum of. So this is the symbol. The symbol is a Greek letter that stands for sum of, and let's say you have it given like this with letters around. So you have in front of the symbol is the general term, and at the bottom what is written in red color is the value to substitute in the general term in order to get your first term. What is written in yellow is the value to substitute in your general term in order to get your last term. So this, in other words, is equal to T1 plus T2 plus T3 plus you have terms there plus your last term Tn. So you have terms in between. You can see this is a series. So this is a shorthand to write a series. I hope you are getting that. It is a sigma symbol, which is a Greek letter used to express the sum of. So it stands for the sum of. Okay, let's move on to some examples so that you can understand all about the sigma symbol. Okay, you have this example. You can see you have your general term there in front of the symbol, the sigma symbol, and you have the value to substitute in order to get your first term. At the bottom, you have the value to substitute at the top in order to get your last term. Okay, so first of all, let's try and get the series to this. Okay, so T1 will be, let me put it in the bracket. You'll get it like this. You use the general term to get your terms, so it will be 2 times n. In the place of n, you replace 1. So you plug in 1 minus 3, close. So this is T1 plus, now it's T2. Since you started from 1, the next value to substitute will be 2. So it will be 2 times 2 minus 3. I'm still using the same general term. So I want you to remember to have this in your mind. It doesn't have to always start from 1. Sometimes you can start from 0. So if you start from 0, the first value to substitute in your general term will be 0, and then you follow by 1, 2, 3, and so on. It can also start maybe from a negative value. Let's say it can start from negative 2. So you know the first value to substitute will be negative 2, and then you follow it by negative 1, 0, 1, 2, 3, and so on. So whatever is written at the bottom will be substituted into the general term in order to get your first term, and then you follow up until the top value which is written at the top to get your last term. Okay, so now let's get our T3. You can see now the next value to substitute will be 3. I'm substituting it in the place of n. And so we have terms in between there plus our last term. I'll use the same general term. And then now I'll substitute what is at the top to get the last term. So I'll substitute 30 minus 3. Can you see that? So what I'm saying is this is your T1 and this is your T2. This is your T3. And then you have terms in between until your last term, which is Tn. Can you see that? Okay. So let's get the values here. So this will be 2 times 1, which is 2, minus 3, which is negative 1, plus the next term, 2 times 2, 4, minus 3, 1, plus the next term, 2 times 3, 6, minus 3, which is 3, plus you have terms in between, plus your last term, 2 times 30, which is 60, minus 3, which is 57. So you can see this is a series we obtained using this sigma notation. Can you see that? So we are not done. We need to find the sum of this series. We need to calculate the series. We have found the first 3 terms and the last term. Okay. Now, before we can decide on finding the sum of the series, we need to identify which type of a series is this. Is it a geometric series or an arithmetic series? Okay, let's see. Let's try and see if it is an arithmetic series. What you normally do is to get the common difference. So you'll take your next term minus your previous term. So if you take 1, can you see that? I don't know if you can see that. You have the minus there. It will be 1 minus minus 1. So this will give you plus 2. So you can see 2 is added to the previous term to get the next term. The same is true if you take 3 minus 1. It will give you 2. So you can see clearly the common difference here is 2. So 2 is the value which is added in order to get the next term. So we say the common difference is 2. And clearly this is what an arithmetic series. So since it is an arithmetic series, you know the formula to use will be this one. If you remember from our previous lesson, to find the sum, it will be this one. Sn is equal to n over 2. Can you remember it from our previous lesson? Or you can use this one. I hope you can remember the formula from our previous lesson. So you have your D, which is the common difference. It is 2. You have A, which is your first term. In this case, the first term is negative 1. And then you have N. We don't know N. I'm going to show you how to find N. So you can use either of the formula. I'm going to use this one, where you have your first term plus your last term in bracket. So N is the number of terms we are dealing with. The number of terms. We want to find how many terms we are summing up, or how many terms are we adding up to find the sum. So to get the number of terms, you will always do this. N, the number of terms will be, you take the top value, which is 30, minus the value at the bottom, which is 1, plus 1. Always the top value minus the bottom value plus 1. Always, let me repeat that. The top value minus the bottom value plus 1. It will give you the number of terms. So this is equal to 30. So we are dealing with 30 terms. We are trying to find the sum of 30 terms. So our sum will be S30. Can you see that? we are going to find S30. So I said I'm going to use this formula. So my n is 30, it's over 2. And then you have a, your first term, which is -1, plus L, which is the last term, which is 57. And then you close your bracket. So I'm saying you can also use this formula. You just plug in everything, every value at the right place. So you have your A, your first term, you have N for the number of terms. We found it 30. I've shown you how to find the number of terms. And then you have D, which is the common difference. Okay, let's use this formula. And then what is now S30? I'm going to use my calculator. I have a calculator there. So I'm just going to plug in what I have there and get the answer. I hope you are following me as I do it. Plus 57. Then you close. So the answer is 840. So S30 is 840. 840. So this is the answer to example number 1. So you can pause the video and use this formula. You'll see that you'll find 840. You'll still find the same answer. Okay? Do you get that? I would like to see your question in the comment below. If you are struggling, if you want clarity on something, just post your question in the comment below. Okay, let's move on to question number, not question number 2, example number 2. Okay, this is example number 2. Now, we need to find the sum of this sigma notation. This is also a series. We can write it in a form of a series. But first, let me find the number of terms, n. What is the number of terms, n? I told you from example 1, you take the top value minus the bottom value plus 1. And then you'll have the number of terms. So this is 8 minus 2, which is 6, plus 1, which is 7. So you are dealing with 7 terms. So you will sum up 7 terms to get the sum. Okay, now we need to decide which type of a series we are going to get from this. So let's find T1, T2, T3. At least we must find 3 consecutive terms in order to decide the type of a series we are dealing with. So T1 will be using this general term in front of the sigma symbol. It's 2, you have 3 there, to the power of k. In the place of k, you replace 2. So I'm starting from 2 to get my first term. So I'll go from 2, 3, 4, 5, 6 until 8, the value at the top, to get my last term. So this will give me, when you check, it will give you 3 to the power of, this is 3 to the power of 1, which is 3 times 2, which is 6. And then T2 is equal to, now I'm going to replace my k with 3 because I started from 2. The next value to replace will be 3. And this will give me 3 minus 1, it's 2. 3 to the power of 2 is 9 times 2, 18. I hope you can see that. And then T3 will give me, you have 3. Now you replace with 4 minus 1. And this will be 3. 3 to the power of 3 is 27 times 2, which is 54. So we have our first 3 terms. You can continue, but let's say the last term, we don't know what it is, so we're gonna call it Tn. It will be, we don't need to find it, let's just leave it. We have 3 terms here. We can deal with this one and then find the answer. Now let's see what type of a series can this be. Can you see clearly there is multiplication by 3? I don't know if you can see that. From 6 to 18, you multiply by 3. From 18 to 54 times 3. So you can see we don't have a common difference. What we have here is a common ratio, R, which is equal to 3. So clearly this is not an arithmetic series. This is what? A geometric series. Can you see that? So since it is a geometric series, we have a formula that can be used in order to find the number of, in order to find what? The sum of this series. So the formula will be this one. You should remember from the previous lesson. And I explained that you can use this formula for any value of R, whether R is greater or less than 1. You can use this formula. There is also another formula, but it's still the same formula. Just use one formula, whether you have the other one or this one. For any value of R, you still find the right answer. You won't go wrong. Okay, now I'm now calculating what? S what? You remember n is 7. We're dealing with 7 terms. So it will be S7 is equal to, what is A? A is the first term, which is 6. And R is the common ratio, 3, to the power of what? N is 7 minus 1 over, what is R? It's 3. The common ratio, we calculated it. You can see, minus 1. So S7 is equal to, let's use the calculator. So I'll just plug in the values I have there. 3 to the power of 7, then minus 1, close bracket, then you have 3 minus 1. So the answer is 6558. 6558. The answer is 6558. So this is the answer to S7, sum of 7 terms. Okay, in example number 3, the question says, what is the value of M for which this sigma notation or the sum or the series is equal to 65? Okay, we need to find the value of M. What is M equal to? If you remember, to find the number of terms, what you do, let's say we use N, because we're gonna have N in our formula as Sn. It's always N. So the number of terms N will be equal to, I told you from the previous example, you take the top value minus the bottom value. So my top value is M minus the bottom value, which is 1. And then you say plus 1. Always top value minus the bottom value plus 1. And this, you can see clearly, this is N is equal to M. Can you see? Because -1 plus 1 is 0. So if you can find the value of N, you have solved for M. Let me repeat that. If you can find the value of N, you have solved for M, because N is equal to M. I have proved it. I have shown you. So what type of a series will this be? Let's see, what is T1? What is T1? So T1 will be 5 times, you have 3 to the power of K. K you replace with 1. So it's 1 minus 1. And this will be, this is 0. Anything to the power of 0 is 1. 1 times 5 is 5. So T1 is 5. What is T2? It will be 5 to the power of, now you replace K with 2 minus 1. And this is 2 minus 1, it's 1. 3 to the power of 1 is 3 times 5 is 15. So you can see we have a series there. What is T3? Up, you can see that you still use the same general term, and then you just replace your value in the place of K. So you're starting from 1 and then you go to 2, 3, 4, and so on. So it will be to the power of 3 now, minus 1, and this is 2. 3 to the power of 2 is 9. 9 times 5 is 45. So this is enough to decide which type of a series this is. Can you see that this is a geometric series because there is multiplication by 3 to get the next term? Can you see that? So you can see that the value of R is equal to 3. R. Can you see? So since this is a geometric series, we can use this formula. The formula for the sum of geometric series. You can use this one. And then we're going to solve for n. So if we find n, then we have solved for m. So Sn will be replaced with what? 65. We are told that the sum is equal to 65. We are given it. So 65 is equal to, what is A? A is the first term. In this case, A is 5. Can you see that? Then you have, what is R? R is equal to 3 to the power of what? We put n. We are going to solve for n. We don't know n. That's what the question is about. As 1 over 3 minus 1. And this will be 65 is equal to 5, 3 to the power of n minus 1 over 2. 3 minus 1 is 2. So we need to get rid of what? Of this fraction, 5 over 2. What we can do is to multiply by 2 over 5 on both sides. Can you see that? And this 2 and 2 will cancel. This 5 and 5 will cancel. So you carry on. You're gonna have on the left side, what you have is 65 divided by 5 is 13. 13 times 2 is 26. So you have 26 on the left side. 26 is equal to what? 3n minus 1. This is cancelled. So I remain with 3n minus 1. And then my negative 1 will move from right side to the left side. It will be 26 plus 1, which is 27, is equal to 3 to the power of n. And 27 can be written as 3 to the power of 3, which is 3. Can you see that? And when the bases are the same, obviously the exponent must be equal. So n is equal to 3. And therefore, m is also equal to 3. We have solved for m. Can you see that? Okay. Okay, now example number 4 says write the following series: 19 plus 22 plus 25 plus, you have terms in between, plus 121, the last term, in sigma notation. So we need to do what? To write it in this sigma notation. We must have what? The general term in front of the sigma symbol and the value to substitute at the bottom there. So if we substitute the value there at the bottom, we must get the first term, which is 19. And then we must also have the value at the top there. And if we substitute this value at the top in the general term that will be written in front of here, it will give us the last term, which is 121. Okay. So we need to find the general term first. Okay, before we can find the general term, we need to identify which type of a series we are dealing with. Let's check, is this a geometric series or an arithmetic series? If we try to see if it is what an arithmetic series, what we do is to take 22 minus 19, it will give you 3. And if you take 25 minus 22, it will give you 3. So I can see there is a common difference of 3. 3 is added from the previous terms to get the next term. So clearly this is what an arithmetic series, and the formula that will work will be this one, if you remember from the previous lesson, to find the general term from the previous term. Can you see that? Okay, so to find the general term, we are going to replace only a and d. So Tn will be equal to, what is a? The first term, 19, plus n minus 1. What is d? The common difference is 3. So Tn is equal to 19 plus 3 times n, you have plus there, it will be 3n. 3 times negative 1, you have plus there, it will be negative 3. And Tn will be equal to, you have 3n. Tn, I've said Tn is equal to 3n, and then you have 19 minus 3, which is 16. So the general term is Tn is equal to 3n plus 16. So let me write it here. So in front of the sigma symbol, you're gonna have 3n plus 16. Okay, now we need to find the value to substitute so that we can find the last term. So the value to put at the top there. So we're gonna use this value 121 to get n at the top there. So I'll replace my Tn with 121. It will be 3n plus 16. When the 16 moves from right to the left side, it will be 121 minus 16. It will give you 105 equal to 3n. Can you see that? And then you divide by 3 on both sides. This will give you, on the left side, you have what you have on the left side here. You must have 35. And on the right side, you have n. So n is equal to 35. So 35 will be there. Okay. So what do you have at the bottom here? You have to replace 19 in the general term, and then you solve for n. Obviously, n will be equal to 1. So you can check it. You just replace Tn with 19 and then you solve for n. So this is the sigma notation for this series. I have solved the question. This is how you write this series in sigma notation. You solve for your general term and then you put your general term in front of the sigma symbol. You solve for the value that can be replaced in order to get your last term, and then you put it at the top. You solve for the value that can be replaced in order to get your first term. You put it at the bottom. Okay, I think I must end this lesson here. I hope it was helpful. So don't forget to subscribe to your channel, share with your friend, put your comment in the comment below, your questions in the comment below. I'd like to see them and help you. So take care and see you next time in the next lesson. Bye.